All right, so we're going to be flipping between worksheet 18 and 19 today and the reference sheet. Everybody good? All right, this is on worksheet 18, and we're going to talk about tangent. Actually already did this question kind of when we were first introducing sine and cosine graphs. I talked real briefly about tangent. We talked about it being the slope. Do you kind of remember that? So we said the slope of a horizontal line was what? When you have a theta of no rotation at all, you have a horizontal line, so the slope is 0. Then as you rotate around, so maybe you're at, pi over 6 or something here, you start to get a little more slope, but it's still positive this whole time, and it's not greater than 1. Where would you have a slope of 1? What do you think about that? Where you go over and up the same amount? What angle would make that the same? 45, yeah. So at 45 degrees or pi over 4, you'd have a slope of 1, okay? But then it gets bigger, right? The slope gets steeper and steeper and steeper. It can be infinitely large. So the graph ends up doing this. It's getting greater and greater and greater until we get here. What is the slope of this line right here?
1.
A vertical line has a slope that's undefined. There's an asymptote in this graph, okay? It is undefined here at pi over 2 because the slope is undefined. And then as we move around into this quadrant, the slope is now a big number, but it's very what? It's going down very steeply, so it's negative. So it's very negative, and then it gets less and less and less and less and less negative. So it's getting closer and closer to 0 until it gets here where it's back to being the same line we started with. So yes, that's where it hits 0, and that was at pi. Now, that's actually a whole period, right? Because if I start going down into this quadrant, is not the slope the same as it was in quadrant 1? It's the same line, right? So the slope is the same. So therefore, it just repeats. And it would be undefined again. Whoa, sorry about that. At 3 pi over 2, which would be here, the other half of this vertical line. Okay? So while we usually draw a tangent, sorry, I'll turn that stupid dinger off. From negative pi over 2 to pi over 2, it doesn't matter. There's 2 periods I've drawn here now. Let's see if I can turn that off. That's here. Sorry. All right, so is this an even or odd function? Any symmetry at all? Origin. Symmetry, so it's odd. I have 18a at the top. Is it 18a? Okay. Not real positive why I have this on here. Oh, it's a graph of tangents. Nice, with sliders. Oh, me. So this is the regular tangent graph. So A is not really called amplitude anymore, guys, because definition of amplitude was max minus min divided by 2. Is there a max or a min here? No. So, but it is, you can put a number out front. All it does is vertically stretch it. Look what happens. It just goes up faster, okay? Or doesn't go up faster if you put something less than 1 in. B, what does B change right in here? Yeah, the period. And what is the period of a tangent graph to begin with? No, pi only. And so when we make this bigger, okay, the period gets smaller, so it happens more often. If we make this smaller, the period gets, well, here, smaller, the period gets longer. All right, if we make the A negative, then it flips. Remember this business? Like a dance move there. All right, let me see if I put these back at 1. H, what is H doing, guys? Yeah, so it's left or right. So, okay, moves asymptotes and everything. And K is a vertical shift. And, whoa, see what K does? It shifts the intercept up or down.
What is that?
We should move all of these, don't you think? We're just having too much fun. Okay, back to what we're supposed to be learning about here. Okay, thanks. Sandra, this is for you. This was interesting real quick. It just says that since tangent is defined as sine over cosine, anywhere, because cosine is in the denominator here, right guys? Anytime that's 0, what happens? Yeah, the tangent has undefined places. Anytime the top is 0, you get 0, so you get intercepts. Okay? Good way to think about it. Properties of the tangent function, you actually have this in a little different form, and I'll look at it. But the big deal is that the period is pi. It crosses through the origin. It has undefined places, and those undefined places repeat every pi. Okay? So the period of pi, any new period, would be pi divided by b. And it really does not have an amplitude. We talked about this because it doesn't have a max or min. Yes. We have never had a negative b value. So we just haven't done any that way. Yeah. All right. This is where you have it on the top of worksheet 19A. It just goes over the fact that sine and cosine, it reviews that those were even and odd and their period and their amplitude, all that good stuff. Here for tangent at the top, it talks about the domain is all real numbers except there's undefined places at every pi over 2, all the odd multiples, so 1 pi over 2, 3 pi over 2, 5 pi over 2. The range is negative infinity to infinity because it goes up and down forever. It is an odd function and it has a period of only pi. Any questions about that one? So this business is not true. We just talked about this, but that doesn't work for tangent, right? It only works for sine and cosine. All that changes for tangent is it's just 1 pi over 2. So do you have this at the top of 18b maybe? Can you find 18b? Okay, it says recall the period of a trig function is changed by factor b when it's multiplied inside. The new period is normally, it's the normal period divided by b. So if it was this question, b is 5, so the new period was 2 pi over 5, right? But what happens when it's tangent, guys? If b is 3, the period is just pi over 3, which actually means you would go have asymptotes at pi over 6 and negative pi over 6 because it's half of it is on either side. What about the first one? What was happening on this? B is 3. Yeah, the period would be 2 pi over 3 because it's a sine graph. And the last one? Yes, B is 4, but because it's tangent, the new period is pi over 4. Does anybody know where the asymptotes would be then? Yeah, it's half on either side, so you'd have one at negative pi over 8 and pi over 8. And so on from there. You would have to add pi over 4. Pretty good. All right, so 19A, let's try to draw this bad boy. I'm not, you know what? I'm not real happy with this negative out here, because we haven't ever drawn one at all, so why do we want to draw a negative one? Let's just get rid of this. Since this is our first attempt, let's just draw a positive one. What is that 4 going to do, though?
Oh, that's
Yes, so if B is 4, our period is,
pi over.
okay? So what did we just discuss? This is the shape, right? As you go to the right, it's positive, okay? We drew a couple periods, it would be doing this. But this undefined place that used to be at pi over 2 has this 4 makes it, how far on either side are we going?
Pi over 8.
Good job. So this entire distance in here needs to be pi over 4. So it's actually at negative pi over, maybe I'll write that here. This is negative pi over 8, and this one is occurring at pi over 8. Where would the next one be? Does anybody know? What would we add on? Oh my goodness.
Pi over.
Well, I got to think about it too. We'd add a pi over 4 on, right? As this length is again pi over 4. So, yeah. Pi over 8 plus another pi over 4. Well, this would be 2/8. So we'd get 3 pi over 8. So where are these intercepts at? This one is 0. This one is how much later? Yeah, it should be pi over 4 because that length, again, from here to here should be pi over 4 because it did the up and the down branch in there. Any questions? Excellent. Okay. This one has a downshift of 5. So it's down here. Notice they stuck it out front. You could definitely have written this negative tangent, I'm sorry, negative 2 tangent of t minus 5. They just put it out front. Still a down. Then normally the 2 would just stretch it up and down. What's the period? Is there a b stuck in there? No, so the period is, be careful, 1 pi. All right, the 2 just stretches it up faster, but what is the negative 2? Yes, this negative makes the shape, instead of going this way, it's going to flip it over and go this way, which is also the shape of a cotangent graph that we're going to talk about. All right, so I'm going to draw it, and then we'll figure out how to label it. All right, so was there a period change? What did we decide? The period was pi, so if this distance is pi, where are these asymptotes at? Yes, negative pi over 2 and positive pi over 2. And the next one would be pi later. What's yeah, 1 pi added on here would be 3 pi over 2. I don't know how to answer that question. There isn't a phase shift. Yes. Normally because it's easier for us to go on either side, I could tell you can't have any negatives, and then you'd have to figure out how to go only to the right, but it's easier if you draw it because it has symmetry around there. So the only other points I would like are this, which was 0, -5. And what would this one be? Anybody know? Yep, right in the middle here would be pi -5. Now, we didn't really do anything with this 2. It just meant it was stretched up twice as fast. And I'm not going to ask you to label anything. I just wanted to show you, I did graph it on the calculator in radian mode. Changed my window and everything. Do you see the difference between these two? How there's 2 of them there? One of them I didn't put the 2 in, and one I did. Do you see that all it did was make it stretch up? This is the one that would have the 2 in it because it goes a little faster and steeper. You see that? That's it. That's all it does. So I'm not going to worry about it. All right, we're going to talk about secant and cosecant. Cosecant is the reciprocal of sine. Okay? The only way to graph it in your calculator would be 1 over and then put a giant parenthesis around a whole bunch of information about sine. 1 over the sine. Now, what it does is it flips every value. So what is the reciprocal of 0, guys? If this is the sine I've graphed in pencil, and that's what you're always going to do. You're just going to graph the sine graph, okay? The reciprocal of 0 is undefined, so this is going to have an asymptote here. Where's the next asymptote going to be? Okay, there would be one here at the end of the period. But is that the only place it hits 0? There's also an asymptote here, and here, and here. Okay, now, tell me where those were, because this was a sine graph, remember? So if this was a sine graph, this is 2 pi. So this is, back here would be -pi, 3 pi. Oops. All right. Now I need you to just think for a minute. If this is 1/10, what is the reciprocal of 1/10? 10. If this was 1/2, the reciprocal of 1/2 would be 2. What is the maximum value right here of a sine graph? A regular sine graph goes from what to what? Up and down. Okay. When I graph a sine graph, if I told you to just graph a sine graph, what is this ordered pair right here? Okay. It's actually pi over 2, 1, right? And the min over here would be at 3 pi over 2, -1. So this is pi over 2, 1. But what is the reciprocal of 1? The reciprocal of 1 is just 1, yes? 1 over 1. Okay. So this value is still here at 1. So that ordered pair we're going to label as pi over 2, 1. Up there. Okay, what happens when I start getting smaller again? I go to 1/2, the reciprocal is 2. I go to 1/10, the reciprocal is 10. You get this shape. And it does continue, can be infinitely large because the sine graph can be smaller and smaller and smaller. It could have been 0.04 here, which is 4/100ths or 1/25th. So when you do the reciprocal, you get 25. Do you see what I'm saying? It can be really big. And the same thing is going to happen over here, except it's going to be very negative. But the reciprocal of -1 right there is -1. So we'd have 3 pi over 2, -1 is that spot right down there. And that's one period, but we could go this way, we could go this way. What I'm going to ask you to graph when you do this are tell me those max or min points and tell me where the asymptotes are. Does that make sense? Okay. So this would be -pi over 2, -1. This one over here would be, what's between 2 and 3 pi? Anybody know that? 2.5 would be?
5 pi over.
Yes. 5 halves pi 1 would be that maximum. All right. But you start by graphing the sine graph, and then everywhere that it was 0, you put in the asymptotes. Everywhere that it had a max or min, you flip it over. And it will, the range, okay, range, I'm sorry, domain. Domain is left to right. It's all real numbers except everywhere that it hits pi. And the range is greater than +1 or less than -1. It's undefined in there. I'm not going to ask you that probably. And because it was a reciprocal of an odd function, it is also an odd function. All right, back on 18. Secant is going to do the same thing. Where are the undefined places? I've graphed you a cosine graph. So where do I put 2 pi on this graph? Guys, where's 2 pi?
Right. Go up. Go down. Right there.
Is that 2 pi?
Oh, no.
Cosine looks like this, right? Right there is 2 pi. So in between here was 1 pi. So where are the asymptotes this time? Or where are the places this one was hitting 0? Pi over 2 and 3 pi over 2. And over here at negative pi over 2. And over here, what's half a pi after 2, guys? Two and a half would be 5 pi. So then the actual secant graph, I'm going to graph in green, would be this one. It would have a minimum here. The green has a minimum at 0, 1. Down here, this branch would flip this way. So this little piece between here and here has a maximum at pi -1. Can anybody give me this ordered pair? Where this one? What's that right there? Yes, pi 1. And if we kept going, there'd be another one over here at 3 pi -1. All right, so you graph the reciprocal graph first. You find the asymptotes wherever it was crossing 0, or the midline, and then you flip them all over. All right. Cotangent is the reciprocal of tangent. So I graphed a tangent graph for you here real quick. What does cotangent do? Well, it flips that over. So everywhere that this original tangent was 0, what happens? What's the reciprocal of 0?
Undefined.
So the undefined places are where the tangent was 0, which was at x equals 0, x equals pi, x equals 2 pi. All right. When the sine and cosine, cotangent is cosine over sine. So what would make it undefined? When the sine is 0 and the sine is 0, remember here's a sine graph. The sine would start here. Okay, that's why those were zeros. But what would make it 0? Okay, if the cosine was 0. So if we graphed a cosine graph, it would have a 0 in here. Does that make sense to anybody that it's going to hit 0 in here. And it goes the other direction because the reciprocal of a tiny number is a big number. The reciprocal of a big number is a tiny number. So cotangent looks like this, where there used to be an asymptote, there's a 0. And where there used to be big numbers, there's little numbers. Okay, you can get the shape idea from your calculator, right? The calculator will help you with the shape, but it's not going to tell you where those ordered pairs go. You need to label the asymptotes, and then you need to label these intercepts. Anybody tell me this one? Over 2, 0. This would be pi later because the period is pi again. So this would be 3 pi over 2, 0. Okay. Is that one cycle or two that I've drawn? One period or two? Two. Yeah, 2 periods because the period is only pi. All right, let's jump to this problem on 18a. It says to graph, and you will be asked to graph one like this on the next quiz, 2 secant 3x. So what do you graph first, guys? Cosine. So first we're going to graph y equals the reciprocal function, which is 2 cosine 3x. Now, you got to be able to graph that correctly. Okay, so I'm going to graph a cosine that goes from what to what? Max and min? Okay, cosine shape is like this. If you want to go this way, you can. You don't have to graph this much. I think the quiz says 2 periods, but all right. What else? I took care of the 2. I graphed the cosine. I need to worry about this 3. What is that 3 telling us? That this cosine finished at 2 pi over 3. Okay, quarter points. 2 pi over 3. We divide that by 4 is the same as multiplying by 1/4, which becomes 2 pi over 12, or pi over 6. So this is pi over 6. This is 2 pi over 6, which is pi over 3. This is 3 pi over 6, or pi over 2. 4 pi over 6 is what we had here. 5 pi over 6. 6 pi over 6. 7 pi over 6. All right. We haven't even graphed our function. How do we graph secant? We take every place that this was 0 and do what? The reciprocal of 0 is?
Undefined.
Okay. So here's our asymptotes. They occur at pi over 6, pi over 2, 5 pi over 6, and 7 pi over 6, which were really 1, 6, 2, 6, or I'm sorry, 3, 6, 5, 6, and 7, 6. All the odd multiples of pi over 6. All right, we did all that work and we haven't graphed the secant yet. What does the secant graph look like? Okay, I'm going to do the secant in purple. The secant graph takes all those little u's and flips them upside down. So it would go this way, this way. This little piece in here would flip up this way. All right, who can give me a couple ordered pairs? What's this one, guys, right here? Over 0 up 2. This one right here, we already labeled it, was pi over 3, but it's down at -2. This one up here is at 2 pi over 3, 2. And this one down over here is at pi -2. Okay, that more fun than you wanted? Actually think last year on the quiz I weakened and said you could just draw one period. Basically, if you draw one period of cosine and flip it over, you should be good. All right. Which of these numbers in this, on 18b, which of these is not going to do much for our graph? The 3. It's going to make it go up and down faster, but that's it. Okay? Just going to stretch it. What does this do? The normal period is?
Pi.
Nope. Tangent. So it's pi. What are we going to do with that? By 4 pi, which will give us 1/4. So the period is supposed to be 1/4. Be careful. Because tangent does what? Well, yeah, it's this shape. So it's going to go a little bit on either side for a total length of 1/4. How much on each side? It's going to go half of this, which is going to be 1/8. There's no pi because the pi divided out up here. So we're going to have an asymptote here and here at 1/8 and at -1/8. And it's a tangent, so it goes like this. That's horribly drawn. Where's the next 0? Where's the next place it would cross the x-axis? Yeah, 1/4. And the next asymptote would be over here at, anybody know what that would be? 1/8. 1/4 is 2/8, so this is 3/8. Says label 2 points or more. Well, we have 0, 0, and 1/4 0. Is that good enough? All right. Can you try this one on your own? What are you going to graph first? Okay, we're going to graph y equals 3 sine 2x. Not the same as the one we just did. Anybody want to come up and try it?
Yeah.
Okay, Kevin, you go for it. I'll narrate for the video. Yeah, remember we're going to flip this over, so you don't want to make it at the very top, because there won't be any room to flip it. There you go. So just graph a sine graph. Keep going a little further. Okay. Do it dotted maybe, because this isn't really the graph we want to graph. You're doing fine. Okay, now let's label some of those points. The period is, okay, so where's pi? Yes. Good job. Yep, I am. Yes. Okay, now let's draw the secant, cosecant, I'm sorry. So take a different color maybe, and draw in the asymptotes. Yep, everywhere that it was a 0. Can you label that x equals 0 at the bottom or the top? I don't care. And there's another asymptote at, yep. Job. Okay. And now maybe a third color, because the actual cosecant graph is where? Yes. You can do that one solid, yep. There's one period, right? You can keep going, but one period would be the up branch and the down branch. Okay. Do we need to talk about ordered pairs? Could everybody write them if they needed to? Pi over 4, 3, 3 pi over 4, negative 3. Be good? Thank you. That was fantastic. Everybody all right? All right. What two things are happening here? Yeah, it's the normal tangent graph. Okay, come on. Sorry. The normal tangent graph would be this shape. Well, not quite, but anyway. The negative is going to take that and make it go this way. So it's going to look more like a cotangent. Okay? But it's still going to go through 0, 0. Where cotangent would be shifted over. Okay, what is the 1/2 going to do? The period is going to be pi over 1/2, which becomes 2 pi. Now, what does that mean the asymptotes are at, though? Because remember, it's a little bit on either side.
Yeah, so
Pi, oh my goodness. Can't draw a straight line. Pi on either side. Oh, okay, try again, Hofbauer. Do it through here. Then it would go through 2 pi again. It'd be another asymptote. So there was asymptotes at x equals negative pi, x equals pi, and there was 0, 0, and 2 pi 0. Is that enough ordered pairs and asymptotes for us? Where would this next asymptote occur, guys? Three pi, because remember the period was 2 pi. Does that make sense? This is a distance of 2 pi, right? So if you did another distance of 2 pi, that help you see that it's 3? This was 2 in here. This would be 3. All right. One more, maybe? Is this the last one? Oh, we got a vertical shift. Okay. Real quick, cotangent. The period is normally pi, so it's going to be pi over 2. But remember, this is an asymptote for cotangent. So the next asymptote is a period later, which is going to be pi over 2. And the next one would be a pi over 2 later, so that would be pi. What is the other thing cotangent does besides it shifts over and has a different asymptote? Is it this shape? Did I do the last one right? No. I did not do, yes I did, this was tangent. No, it was a negative tangent. No one stopped me. What could have happened? Yeah, these are the negative tangents. Not the blue one. I messed up. Okay, so this one is cotangent, which is also going this way. All right. Are we out of time? Okay. So this is the assignment. Guys, this last question, is everybody listening? This last question is like this. All you do is you graph it on your calculator. Y1 equals 2 divided by cosine of x. Y2 equals 5 times the sine of x, because secant is the reciprocal of cosine. And then you find decimals where they intersect. And the directions say like between 0 and 2 pi or something. Decimal intersection points. Okay. I'd like to say I hope I see you tomorrow, because I would be here if we had school tomorrow, but yeah.